subnetting process and see how we can implement subnetting. And by the way, here at the moment, the type of subnetting that I'm discussing with you is called a fixed length subnet mask. Fixed length subnet mask, FLSM, right? So in a minute, we'll also talk about variable length subnet mask. So let's assume that we have asked our ISP for a Class C license, and we are given a Class C address of 206.15.143.0. Obviously, we know that's a small block, and let's assume that um, we know this, right? That this is one network, means this address will give me one network address, which is obviously this 206.15.143.0. And how many number of nodes I can create with this one subnet? Yes, 254. How? 2 raised to power the number of bits in the host portion. How many number of bits are there in the host portion? Yes, you're right, 8. So 2 raised to power 8 minus 2. So this means 254, right? So having one network against this IP address, I can assign IP addresses to 254 machines. But what if I want to, just for the sake of example, what if I want to break down this network into 5 smaller networks, 5 subnets, and each subnet must be containing 25 nodes. So this is a sort of a requirement for subnetting, right? So how many number of subnets I have to create? So this gives me this point basically identifying the requirements of the subnetting process. How many subnets are required here? Yes, we need 5 subnets. And how many number of nodes per subnet? Nodes per subnet? Yes, 25. So what I want to do is, we want to divide this one network into 5 smaller networks, means 5 subnets, and each subnet should be having 25 addresses for n machines. Okay, so let's see how we can do it and how we can implement this subnetting process. So first of all, we need to calculate that how many number of bits we need to borrow from the host portion. Remember, in subnetting, we have to borrow bits from the host portion for the subnetting process, right? So how many number of bits we have to borrow? So we have to do a little math to see how many number of subnets can be created, as we have seen in the previous tables. So let's see. What do you think if I borrow 2 bits? What will happen? So 2 raised to power 2 minus 2. How many subnets I can create? 2. Right. So if I borrow 2 bits, I'll be able to create 2 subnets. Right. So is this enough? No, it's not. Why? Because our requirement is to create 5 subnets. So let me increase the number of bits that I can borrow. Fine. So what if I borrow 3 bits? So 2 raised to power 3 minus 2 is 6. That's okay, right? This is enough for this subnetting process. Why? Because we want to create 5 subnets, right? So this means 3 bits are enough, right? So we are done with the first requirement, that is about the number of subnets. This means, okay, I can do the subnetting process by borrowing 3 bits, but what is left in the host portion? How many number of bits are left in the host portion? So 3 bits are borrowed, 3 bits have become the part of the network address. This means 5 bits are left for the host addresses. So what was the requirement of nodes in each subnet? So what do you think, how many number of nodes are required? So yes, the requirement is to have IP addresses for 25 nodes. So we have to again see that is it still possible to assign IP addresses to 25 nodes with the remaining bits in the host portion? We can quickly evaluate. So 2 raised to power the number of bits in the host portion. So how many bits have been left in the host portion? Yes, you're right, 5. So 2 raised to power 5 minus 2 is 30. Right, so this means we are good to go, right? So this means we can have, by borrowing 3 bits, we can create 6 subnets. We require 5, and we need to assign addresses to 25 nodes, but we have 5 bits in the host portion, so 2 raised to power 5 minus 2 is 30. So this means we can assign IP addresses to 30 machines in each of these 5 subnets. So this means borrowing 3 bits will is, is, is enough for us. So again, so we can have a look at it. So the requirement is to get how many number of subnets, to divide this network into 5 subnets. So we'll be borrowing 2 raised to power. We'll be borrowing how many bits? 3 bits. So this will give me 6 usable subnets, which is enough to fulfill my requirement. And how many bits are left in the host portion? Yes, 5. 2 raised to power 5 minus 2 means this will give me 30 nodes per subnet, and the requirement is to have 25 nodes. Right. And the remember the first step in subnetting is there are 3 steps basically. The first step is to straight away calculate the subnet mask. So the first thing that we'll do is to calculate the subnet mask. Okay, and the next step would be to assign subnet addresses. Subnet addresses. And then the third step would be to assign host addresses. Okay, so first we'll try to calculate the subnet mask, but let us see what is the situation in class C, right? So this is the default arrangement, right? So this, we know that the first 3 octets here represents the network portion. So these octets represents, this octet is the network portion, this octet is the network portion, right? So the first 3 octets represents the network portion. This is the default arrangement, by the way, right? And the last octet represents what? The host portion, right? Means at the moment of the default subnet mask, we all know is 255.255.255.0. Okay, but and this is obviously the masking representation at the moment here. So the value would be, yes, 255.255.255.0. So what we have done now, since we have borrowed 3 bits from the host portion, so these 3 bits have become the part of the network portion, right? And if I now want to calculate the subnet mask, so what I have to do is, yes, so just look at the binary representation here. So this was by default, right? So the first 3 octets all are, having all the bits are 1, because this is by default in the subnet calculation process, right? So we can change it. So what we have done here is, now we have, borrowed 3 bits, and these 3 bits will be representing what? This would be representing the network portion. And now we can easily calculate the subnet mask, which is the first step in the implementation of subnetting, right? So we know that this is by default, all the bits are 1, network portion, all the bits are 1, network portion, all the bits are 1. So 255.255.255. How many number of bits are borrowed? 3. And yes, the value of this bit is 2 raised to power 128. What is the value of the second bit? 2 raised to power 6. 64. What is the value of this bit? 2 raised to power 5. 32. So we'll add it up together, and the subnet mask now would be 255.255.255.224. This is a straightforward step, and the first thing is to calculate to come up with the subnet mask. So this is our subnet mask that we'll use uh, uh, in this subnetting process, and we'll see how it is beneficial, right, in a minute. Okay, so the first step is to calculate the subnet mask, and that depends how many number of bits are borrowed, right? In this case, we borrowed 3 bits from the host portion, first 3 octet by default, all the bits are 1, so the value is 255.255.255, and since we have borrowed these 3 bits, so we'll add the value of these 3 bits, and now the subnet mask is 255.255.255.224. And the next, what was the next phase or the step? Yes, the next step is to calculate the subnet addresses, right? So for the subnet addresses, we need to see how many usable subnets we can have. So how many number of bits are borrowed, by the way? Yes, 3. So 2 raised to power 3 minus 2. So the number of usable subnets are 6. Why we are doing this, subtracting this 2? Yes, we will not use all the zeros and all. So we will not use all the zeros and all the ones. So we are left with 6 usable subnet addresses and see how we can assign a subnet address. So let me remind you the position in the last octet, the values in the last octet, right? So this is the last octet. We have 8 bits, right? And these are the values of the 8 bits. And let me have the first combination here. What is the first? I'll not have all zeros, right? So I'll not be using all zeros here. I'm not using all zeros here. What if I'm using all zeros? What will happen? Yes, you're right. I'll have the same network address. This will not be a subnet address. Okay, so I'll apply the first combination. That is, since we can have total 8 combinations and we are using 6 usable subnets or combinations where I'm not using this, all zeros. So the next combination is 001. So look at these bits. Which bit is on here in this last octet? I'm not dealing with these bits at the moment. Why? Because the bits represents the host portion. So I'm not dealing with the host portion at the moment. So which bit is 1? Yes, 32. So what will be the value of the last octet? 32. Okay. Similarly, let me put the second combination here. 0, 1, 0. Which bit is on in this case? 1. And I'll have the value of the last octet, 64. Let me put the next combination, 1, 1. What will be the value of the last octet now? 96. See, I have only borrowed 3 bits here. What if I have borrowed up a complete octet? So how many combinations would have been there? 254. So it's not feasible to put every combination. So what we can do is we can put the first combination here, 001, which will give me value 32, and I'll add 32 into 32. So this will give me the next address, which is 64. And again, I'll add 32 and 64. I'll get the next value, which is 96, and I'll add again 32 into 96, and it will give me the next value, which is 128. And we can also see by applying the combination on this side as well. Now I have applied this combination 100. So this means what? This means bit number 128 is on, and the value of the last octet would be 128. The first 3 octets are assigned by my ISP. I cannot change it, and by applying different combinations of the bits borrowed for the subnetting, I can have these values: 32, 64, 96, 128, and I'll again add 32 into it. Yes, this is combination 101. Which 2 bits are on? Bit number 32 and bit number 128, and the value is 160. And I'll again add 32 into it. Means the combination 110. Which values are on? Which bits are on? The bit representing value 64, or the bit having the value 128. So 128 plus 64. Yes, 92, right? So, so this way we can have the subnet addresses, right? Which is very clear here also. So these are the combinations that I applied, and these are the values of the last octet: 32, 64, 96, 128, 160. And if I'm not, if I don't want to go through this tedious process of placing the combinations and calculating these values, so I can apply the first combination, which will give me the first value, that is dot 32 in the last octet, and I'll add 32 into 32. I'll get 64. I'll again add the first value, 32 into 64, which will give me 96, and again add 32 into 96, 128, add 32 in 128, 160, and so on and so forth, right? So these are the usable subnet addresses, right? So this we already assigned by our ISP. We cannot change it. Why? Because 206.15.143.0 was assigned by the ISP. This identifies my network address. right? So this is the first subnet value that I can have by applying the combination 0, 0, 0, 0, 1, and the value of this bit is, we know that, 32, right? So this is the first subnet address. What is the second subnet address? Yes, 206.15.143.64. What is the value of the next subnet address? 206.15.143.96. 206, again I add 32 into 96, 206.15.143.128, 206.15.143.160 by adding 32 again into 128, and then 192. So these are the 6 usable subnets that I can use to create host addresses. Now the third step is to calculate or to assign addresses to the nodes, right? So again, let me present to you the scenario in the last octet, because we are playing with the host portion, right? So this color here is representing the bits for the network part, or let me call it, these are the bits representing the subnetwork, right? Having address, yes, having address 206.15.143.32. Okay, so no, I will not change the subnet bits, and I will change the values in the host portion. So while calculating this address, all the bits in the host portion were 0, right? So now let me put the first combination here, 0, 0, 0, 0, 1, since 5 bits are there in the host portion. So what is the value of what will be the value of this octet now? We know its value is 32, right? Plus what? What is the value of this bit 2 raised to power 0? Yes, 1. Okay, so 32 plus 1 is 33. So this is the address of the first node in this subnet, 206.15.143.33 is the value of the first node in the subnet, 206.15.143.32, right? And again, I do not need to have the next combination, right, like 0, 0, 0, 1, 0, right? So what I can do is simply I can add 1 into it, right? The value of the next node would be 206.15.143.34. I'll again add 1 into it, 3500, and so on and so forth, right? So this means the last address of the node in this case would be 63, right? To 206.15.143.63. Why? This is this combination, by the way. And if I also turn on this bit, the address would be 206.15.143.63. But I cannot do it. What happens if there are if all the bits in the host portion are 1? We have just covered it. Yes, it's the broadcast address, right? So this will give me the address 206.15.143.63, but this is the broadcast address of the subnet 206.15.143.32, right? So I cannot assign a broadcast address to any machine, obviously, right? Okay, so let's talk about the next subnet, which is 206.15.143.64, and let's see how we can assign addresses to individual nodes here. So again, let me present to you the scenario. In the last octet, this bit is on. Yes, this means this value is 64, and now I turn on this bit in the host portion by applying this combination 0, 0, 0, 0, 1, and its value is 1. So 64 plus 1 is 65. So this is the first this is the address of the first node in the octet 206.15.143.64. Similarly, the last address in this case would be 206.15.143.94. And if I turn all these bits 1, by the way, the value of this, the combination representing 94 is this. Okay, so we can calculate it easily. It's not difficult. Its value is 64. So and its value is 16, 8, 4, 2. If we add them together, the value is .64. And if I also turn this bit 1, the address would be 206.15.143.95, but we cannot assign it to a node. Why? Because this is what? This is the broadcast address. Okay. So we can see that this is the broadcast address because all the bits in the host portion are 1. Okay, similarly, we can have node addresses in the other subnet also. So this is the range of the nodes in other subnets also, right? So this is how, in 3 steps, we can calculate or we can implement subnetting. I'm talking about fixed length subnet mask at the moment. So number 1 is to calculate subnet mask. Very straightforward, right? It depends how many number of bits we have borrowed. The bits that we have borrowed from the host portion will have value 1 now, and we will calculate subnet mask. And then we will calculate subnet addresses. And then after calculating subnet addresses, we will calculate node addresses. And this shall complete our subnetting process. But I just want to talk about the subnet mask, that how the subnet mask is helpful in identifying that to which subnet our destination machine belongs to. Let's try to look at it. So let's see how to find the subnet address. So let's assume that a packet has arrived at the router with the destination address 206.15.143.89. So .89. So now we know that we have 5. Now we know that we have 5 subnets here. So we have to identify to which subnet this destination address belongs to, right? And for that, we have provided the router with the subnet mask, right? 255.255.255.224, since 3 bits were borrowed. So what we do is we will represent the destination address into binary. This is the binary representation of 206.15.143.89. And we'll again represent the subnet mask into binaries. And we'll do a logical AND here. And whatever is the result would be the subnet that this machine belongs to. So if I do a logical AND, the result is 206.15.143.64. So this means router will forward this incoming packet to the subnet 206.15.143.64. So this is why we use the subnet to help router to do this logical bitwise AND operation of the incoming packet having specific destination address and the subnet mask that we have calculated and provided in to the router to determine which subnet this packet will be forwarded to. Okay.